Hey everyone, welcome to Chapter 3, Section 3, Slopes of Lines. In this section, I'm going to go over the slope formula. So you'll recall that you've seen the slope formula from Algebra 1. The slope of a line can be calculated using any 2 points on that line, and it should be the same slope every time. The slope's not going to change on the line, otherwise you have a line changing directions and stuff like that. So you'll recall that the slope means it's the pattern of the line, right? So you can represent the pattern by calling it the rise over the run. You might also have heard your teachers say it's the change in y over the change in x. We're going to be calculating the slope by hand, so we'll be using the slope formula, y2 minus y1 over x2 minus x1. And that's going to equal m. I've just realized I left that out, so I'll write equals m. The reason why I wrote equals m is because m stands for slope from the slope-intercept formula. You know, y equals mx plus b. M here is your slope. Okay? So all these examples I'm going to be writing m equals next to all of them. So this first example here, these are just graphs. I don't have to do any of this y2 minus y1 or x2 minus x1. I just need to look at the pattern of the line. So I have a couple of labeled points here, J and K. What I like to do is I like to see if the line goes through any other corners of the graph to see if it's easier, if there's any points closer together. That's what I mean by easier. And it doesn't look like there is. So J goes up 1, 2, 3, 4, 5 units. And then it goes over 1, 2, 3, 4 units. Okay? So if it went up 5 and over 4, you say your slope is m equals 5 over 4. You'll want to leave your slope as a fraction because it's very easy to graph points going up 5 over 4, up 5 over 4. If you converted it to a decimal, that would make 1.25, and so you'd be going up 1.25 over 1, up 1.25 over 1, and so on. And it's just like not nearly as easy to graph. So always leave your slopes as a fraction. Letter B, I have this line. It's going down from left to right, so that tells me I have a negative slope. So if I look at point L here, it goes through this corner here, goes through another corner down there, and then goes through another corner down there before it gets to M. So like you don't have to use L and M. I can just go down 2 over 1. So down 2 over 1, I would say that is a slope of m equals negative 2 over 1. And anything divided by 1 is a whole number, so you could also just write m equals negative 2. Okay? So part C, this is a zero slope line. How do you know it's a zero slope? Well, it's rise over run, right? So it's not rising at all. It's not going up at all, is it? So it's just running. So it's 0 divided by, I don't know, infinity or something. Is 0 divided by any number. So if I were like to count the spots in between n and p, that's 1, 2, 3, 4, 5, 6, 7. I would just write m equals 0 over 7, and which just equals 0. So m equals 0 over 7. It doesn't really matter what number's on the bottom. 0 divided by anything is 0. So simply put, just put m equals 0. Okay? On letter D, there is a rise, but there's no run. Okay? So let's see here. It rises between R and Q. I'll just use those. It goes up 1, 2, 3, 4, 5. And then it doesn't run at all. So I would say m equals 5 divided by 0. And if you recall, you cannot divide by 0. If you type in 5 divided by 0, your calculator will give you some sort of error message. So this kind of slope is called an undefined slope. So there, I just wrote down that slope is undefined. That's that key word right there. That's what you would just say. Undefined is your answer because you cannot divide by 0. All right? So that leads me into my next point here. You have, traditionally, you have 4 types of slopes. You have positive slopes, that's what this is. Negative slopes, that's what this is. Zero slopes, and undefined slopes. Positive slopes go up from left to right. Negative slopes go down from left to right. And zero slopes are completely flat horizontal lines, and undefined slopes are completely vertical lines. They're completely straight up and down. So let's move on to some additional examples. So not only are there positive and negative slopes, but there's and zero and undefined, but there's also parallel lines and perpendicular lines, and you determine if a line is parallel or perpendicular by the slope. Okay, so parallel lines are going to have the same exact slope, the same number, same sign. Okay, so in this picture right here, I have two lines. They're marked as parallel, which is nice, but the slope is given as 4. You know it's 4 because you read it from left to right, right? So it's like start here where it goes through a corner and it goes up 1, 2, 3, 4 units over 1 before it hits through another corner. So that's kind of how you can verify that the slope was 4. So these parallel lines have the exact same slope, all right? And then perpendicular lines are lines that intersect at a right angle, okay? So that's 90 degrees, and they have opposite reciprocal slopes, meaning you flip the sign and you flip the fraction. So 4 is a whole number. So if I were to write it as a fraction, I'd write it as 4 over 1. And so if I were to flip it, that'd be doing the reciprocal. That'd become 1 over 4. And then since I said opposite reciprocal, I say it's negative 1 over 4. So here's a perpendicular line going through these parallel lines, and it makes a right angle at the point of intersection. Any other intersecting lines, if you have differing slopes but they're not opposite reciprocal, they're not considered perpendicular lines. They're just considered intersecting lines, I guess. But yeah, you have two special types of lines, and that's parallel and perpendicular, okay? You can have parallel lines with negative slopes or positive slopes or zero slopes. You could have parallel lines that are completely vertical with undefined slopes. So yeah, I guess same thing with perpendicular as well. What I'm going to do next on example 2a and 2b is I'm going to calculate the slope with using that aforementioned formula, y2 minus y1 over x2 minus x1. And I'm going to calculate the slope between these 2 points on A, B, and C, D, and determine if the lines are parallel, perpendicular, or neither. Okay, so I just rewrote down the points for A and B so I didn't have to zoom out and in, and I rewrote down the slope formula. So you know what points are x1, y1 just based on the order that you read it. X1, y1, x2, y2. So for my slope, I'm going to say m equals negative 5 minus 1 divided by negative 1 minus 1. You're welcome to type this into a calculator all at once. I like to simplify them to show my work. But if you are using a calculator, make sure you use parentheses on the numerator and the denominator, the top and the bottom of the fraction. So that way it does it correctly. Otherwise, because of the order of operations, you'll get the wrong answer if you don't use parentheses. But anyway, negative 5 minus 1 is negative 6. And negative 1 minus 1 is negative 2. Negative 6 divided by negative 2 is 3 over 1, or simply just 3 if it's a whole number. So whenever you're working these slope problems, I'll want you to reduce the fraction. And if it's a whole number, if you write it over 1, that's no big deal. But if you get a fraction like 25 over 50, 25 is half of 50, I'll want you to reduce it to 1 over 2, okay? Okay, so I'm going to compare that slope to the slope of line CD. So C's at 3,2, D's at 6,1. So I went ahead and I labeled them as x1, y1, x2, y2. And then just to be consistent, I wrote down the slope formula again. So I'll plug in 1 minus 2 over 6 minus 3. And again, if you're using a calculator and you want to do it all at once, that's fine. Just make sure you use parentheses. But I'm going to simplify the numerator and denominator. So 1 minus 2 is negative 1. 6 minus 3 is 3. So yeah, you can leave it as negative 1 over 3. You know, whenever you write negative fractions, typically you'll see the negative written with the top number, or you could see it written on the side. But this is another fraction answer, so you'll just want to leave it as a fraction. Don't convert it to a decimal. But you see here I had positive 3 and negative 1 over 3. So I have opposite reciprocal slopes. If I flip the fraction of 3 over 1, it turns into 1 over 3. And if I change the sign, it's now negative 1 over 3. So I'm going to say these are perpendicular. Okay, so I have a similar example comparing the lines of FG and HJ. So here are the points for FGH and there are the points for J. I'm going to rewrite these, of course. So here are my points for F and G. I'll want to label those as x1, y1 and x2, y2. Okay, so my slope formula is change in y over change in x. So m will equal y2 minus y1, negative 1 minus negative 3 over negative 2 minus 1. The most common mistake I see kids make is whenever they're minusing a negative, they think, oh, the formula has a minus in it already, so they don't need to write the minus like for with the minus 3. But no, you do need to write that. You always carry the sign with it. So you might have a minus a negative. So that's very important that you remember to do that. Because if you don't, you get a very different answer. So negative 1 minus negative 3 becomes negative 1 plus 3, and that'll make 2. Whereas if you did negative 1 minus 3, you'd have negative 4. So yeah, again, very different. So the denominator will say negative 2 minus 1. That makes negative 3. And again, I mentioned it earlier. Typically, you'll see fractions, negative fractions. The negative will be written on the side or with the number on top. It's, technically not wrong. It just looks better when the negatives, it's not wrong if the negative's on the bottom or the denominator. It just looks better if it's just on the side or on the top. So HJ is at 5, 0, and 6, 3. So the points for H will be my x1, y1. The points for J will be my x2, y2. So I'm going to do 3 minus 0 over 6 minus 5. So 3 minus 0 makes 3, 6 minus 5 makes 1, and 3 over 1 is just 3. Okay? So let's compare our slopes now. We had positive 2/3 and positive 3. Oh, negative 2/3, sorry. Negative 2/3 and positive 3. So they are completely different. So they're not parallel, they're not perpendicular, then they're neither. These lines would eventually intersect if we were to graph them, but they wouldn't make a right angle when they intersect. So you can't say they're perpendicular lines. You just simply say they're neither. Okay, so I got one more example. Example 3 says, what could the coordinates of point B be if it is on the line that contains A and is perpendicular to C and D? So this sounds kind of weird. I tried wording it the best I could. But what I'll do is I'll calculate the slope of CD first. So y2 will be 0 from the point D, minus y1 is a negative 3 from point C, and then over x2 is 2, and then minus negative 2 from x1. All right, so that's going to give me 0 minus negative 3 is positive 3. 2 minus negative 2 is positive 4. So I have a slope of 3 over 4. So the question says, what could the coordinates of point B be if it's on the line with point A and it's perpendicular? I need a perpendicular slope. So the symbol for perpendicular is like an upside down T. So my perpendicular slope is going to equal the opposite reciprocal. So negative 4 over 3. So what I can do now is I can plot my points. I'll start with plotting point A at negative 3, 0. All right. And then I'll use my perpendicular slope of negative 4 over 3 to plot an additional point. So I'll label this as A. And then I'll go down 4 spots. 1, 2, 3, 4 over 3. 1, 2, 3. So I'll call this point B. That's why the question was worded kind of vague. What could the coordinates of point B be? Because obviously I could keep going down 4 over 3, down 4 over 3, and it could be any one of those points, but it wouldn't fit on this little graph I have here. So yeah, if you were to connect these dots and draw your line, and then plot your points C and D, they should make kind of a nice X when you draw your lines, because you know, if they're forming right angles, then you kind of have a nice X, and you can put right angles in between an X, I would think. A symmetrical X, that is. But yeah, I'm kind of rambling on. The point I'm trying to make is point B would be at 0, comma, negative 1, 2, 3, 4. So that's the basically all I'm looking for. I would just write down B at 0, negative 4. And I figured that out because I used the slope from my line CD, and then I did the opposite reciprocal of that to plot an additional point. And that's how I figured out what point B would be. So I hope this video was educational, useful to you. If you learned something, hit that like and subscribe button. I don't really care, but thank you for watching, and goodbye.